Hi. In this lesson, we're going to be working with integer and rational exponents. Before we begin, we first have to learn a few rules that are going to help us make us more successful in this lesson. You ready to begin? Let's get started. So this chapter is going to deal with a lot of exponents. Now, when we deal with exponents, we have to also know what are bases. So what we have to always remember is there's certain rules that apply to exponents and bases. In case we forgot, this right here is called a base. And this right here is called an exponent, or also known as a degree, which you'll learn later on in the chapter. A base has to be the same if we're going to be able to combine two exponents. Now you're going to notice that all these letters say a as our bases, and it's just because a could be any number or any variable. When you have two bases that are the same and you're multiplying these two bases, kind of this example right here, a to the x times a to the y, what I'm going to do is if you have the same base, you're allowed to combine the bases, so it's just simply a, but what you're going to do with the exponents is you're going to simply just add them. And this is called the product rule. The quotient rule is, well, if I'm dividing two bases that have exponents, I need to first make sure the bases are the same, and if they are, what I'm going to do is I'm going to subtract the exponents. So product represents addition of the exponents. Quotient means you're going to subtract the exponents. These are rules you want to write down because you're going to be using them over and over in this lesson. So again, product means you're going to add the exponents, and quotient means you're going to subtract the exponents, but the bases have to be the same. Then you're going to go to a rule that a lot of students will get confused with. It represents the power rule. The power rule is saying that if I ever have a power to a power, remember a power just represents a degree, which also represents an exponent. They're all words that you're going to see and use that can be interchangeable. So when I have a power to a power, an exponent to an exponent, I'm simply just going to multiply them. So in this example, I have a to the x to the y. Because I have a power to a power, I'm going to multiply the x and the y and leave it as an exponent. So my answer would be a to the xy, whatever this represents. Now, one that's very tricky is the negative exponent rule. What I always want you to remember about negative exponent rule is you are not allowed negatives in a problem as an exponent. So if you ever have a negative on the bottom, you're simply just going to bring the entire base with the exponent to the top to join the 1. So this a to the y, negative y, will go to the top. And when it rises to the top, it will become positive. Okay? So for example, let's just say as well, let's say I had x to the negative 5. I can't have a negative exponent. So what would happen? I would create a fraction, and then I'm going to bring x to negative 5 in a different location. How I bring it is if right now it's on top because technically it's over 1, it's going to join the bottom. So this entire thing is going to go to the bottom. So now my bottom is x to the 5th. The question is, what is the top going to be? The top is going to be a 1. So the negative exponent rule says this. If you have a negative exponent in the bottom, bring it to the top. Or if you have a negative exponent on top, you're going to simply bring it to the bottom. Okay? We're going to have a lot more practice with this one, but the reason why I wanted to do an example with this one, negative exponent rules usually confuse students the most between all the rules that we have. The next one after this is called the zero exponent rule. To be fair, the zero exponent rule is simply this. If you ever see that your entire base is being raised to the 0 degree, the 0 exponent, your answer will always be 1. Always. So anything to the 0 will always be 1. That's a rule that most students are going to forget because it's so easy to remember, also easy to forget. Now, lastly, you're going to have the rational exponent rule. The rational exponent rule is whenever you see that your base is raised to a fraction. Whenever your base is raised to a fraction, what I want you to do first is I want you to be able to rewrite this in the proper way. How do you do this? What you do is, I can't cover with my finger, but what I want you to do is cover the denominator. If you cover your denominator, this reads like any other problem, a to the x. That's why your base in the inside of the root is a to the x. So every single time that you have a to a fraction, cover the denominator, and whatever you see in the numerator is going to go in the inside. Now, what's on the outside is your denominator. Your denominator will always go on the outside, which is called the index. Okay, that number is going to be used later on in the lesson. So again, once again, every time that you have a a base to a degree and your degree happens to be a fraction, you have to rewrite it. You rewrite it with a radical, which is called technically a root, and your exponent, which is your numerator, is going to stay in the inside, and your denominator is going to come on the outside. Okay, covering up the denominator is going to help you out, but it's something that you have to take a lot more practice in. Okay, so we ready to begin? Let's get started. In our first example, it says simplify your answer by using the product rule. Well, remember, product rule is when you're multiplying bases, but notice something. You have numbers and variables. The only variable that we have is x. So taking a page out of our previous chapters, every time that we have an x, we want to write a degree of 1. Why are we doing that? We're doing that because we want to be able to know that this degree is 1. We're multiplying all of our bases. But imagine all of the x's weren't there. I would have 2 times 4 times 2. So when you work with numbers, treat numbers individually than you do with variables. They don't go together. 2x squared is not together. This is really 2 times x squared. So remember, treat numbers first, then variables afterwards. So if I combine all the numbers, I got 2 times 4 times 2, which hopefully you agree 2 times 4 is 8, and 8 times 2 is 16. So I know the outside of this is going to be 16. Now next, I have to work with all of my exponents. Well, remember we said product rule is taking all of your exponents and adding them. So I'm going to add 2 plus 3 plus 1, which I hope you agree is going to be 6. So my final answer for this is going to be 16x to the 6. So again, multiply your numbers because you're multiplying and add all the exponents. All right, next one. If you want, pause the video, try it on your own, and see what you get. Okay, first step. Now we're working with y's. It's okay. What I want you to do is I want you to technically work with the numbers. So I'm going to put a 1 in the exponent. And then I'm going to multiply all the numbers in the front. I have technically a 2 times a 2, which I hope you agree is 4. And then with the variables, I'm going to add all the exponents. 3 plus 1 plus 4 is going to be 8. So my final answer is 4y to the 8. And that's my final answer. Hopefully that wasn't that bad. But you have to remember, when you do product rule, you're going to add the exponents when you're multiplying the bases. Okay? All right, in example 4, we're now going to move on to quotient rule. If you remember, quotient rule means subtracting the exponents when you're dividing the bases. So I'm going to look at this problem. Whenever I deal with a fraction, I always like to answer my fraction with the fraction. So I'm going to first work with numbers individually. Like we said, treat numbers individually from variables. 2 over 4, you can divide both of them by what number? You can divide them both by 2. If I divide the top by 2, I get 1. And if I divide the bottom 4 by 2, I get 2. Now I'm going to work with the exponents. This is the part that it gets tricky. And this is the part that I want to make sure that we use the same strategy for every single type of problem. When I have to subtract the exponents, I have 2x cubed over 4x to the 8th, right? The 2 over the 4 became 1/2. And now I have to subtract 3 minus 8. But if I subtract 3 minus 8, I hope you agree you get x to negative 5. But then you have to learn a rule that we learned in the past that says a negative exponent can't happen. So if we have a negative exponent on top, where does it go? It goes to the bottom. So this would be written as 1 on top because it's different, 2x to the 5th. And that would be my final answer. Why? Because I subtracted exponents. Now, what's the shortcut? I like to do it a little bit different because I don't want to work with negative exponents. So this is the rule we do. If I was going to do this method, this is called method 1, and now I'm going to try method 2. Method 1 is still set up a fraction because you're working with a fraction. I'm going to simplify the 2 over 4, which gives me 1/2. And then now what I'm going to do is I know that these bases are the same, so I'm going to subtract the exponent. All I want you to do is I want you to subtract the exponents like normal. Bigger minus smaller. 8 minus 3. What's 8 minus 3? 5. Ask yourself now, between x to the 3rd and x to the 8th, which number is bigger? X to the 8th. Where is x to the 8th? It's on the bottom. So my answer is going to be x to the 5th, but on the bottom. And you'll notice we get the same exact answer as before. We didn't have to work with negative exponents. The reason why this is so important, we want a setup. And I like to work with numbers as bigger minus smaller and not worry about negative numbers. The rule is wherever you see that your x is bigger, that's where it's going to remain. Okay? All right. Example B, if you'd like, try it on your own. and then press play, and then I'll be able to hear to answer the question. So B for me, it's a fraction, so I'm going to lead it with a fraction. I'm going to do 8 divided by 2, which is 4. Where is it bigger? 8's bigger, so 4 is going to go on top. I'm going to work with the y's, but I'm going to stop because I don't like y to the 5th over y to the what? Remember, there's always an imaginary 1. You're going to subtract the exponents and put it where it's bigger. 5 minus 1 is 4. It's bigger on top, so I'm going to put y to the 4. Now I don't have anything on the bottom, so because of that, I could either put a 1, or we could just erase it and write 4y to the 4. And that's my final answer. And this is called the quotient rule. Okay? So now for example 3, we're actually going to be doing a combination of the both, of a product rule as well as a quotient rule. Now remember, product rule means we're going to be multiplying bases, which means we're going to be adding the exponents. And quotient rule means we're going to be dividing the bases, which means we're going to be simplifying by subtracting the exponents. But what happens when we have to do the combination of the two? So you ready? Let's get started. So for example A, we notice that it starts off with a fraction. There's numbers like 9 over 6, treat them separately than the variables. And I have x's on top, y's on the bottom, and I have z's on top and bottom. Okay, so the first thing that we're going to do is we're going to clean this up by putting exponents of 1 around the z. Why do we do that? We want to stay organized. Next, what we're going to do is we're going to write a fraction so that we can figure out what goes where and how do we simplify this. So first I'm going to start off with the numbers 9 and 6. I'm going to ask myself what number goes into 9 and 6 that they both have in common. Hopefully agree it's a 3. So I'm going to divide 3 into 9, and that's going to give me 3 on top. I'm going to divide 3 into 6, which is going to give me 2 on the bottom. I'm next going to, and this is the part where it doesn't really matter where you go. I like to go alphabetical order, so I'm going to go with x first. I have x to the 4, x to the 2 on top. That means they're technically being multiplied. Why? How do I know? Division means they would be on top and on the bottom. So I'm going to simplify the x's on top by adding the exponents. 4 plus 2 gives me 6, so I'm going to put x to the 6 on top because it's already on top, so it remains where it's at. When it comes to the y, where's the y's? The y's are in the bottom. So I'm going to combine the exponents by simply just adding them. Why am I adding them? Because technically they're being multiplied underneath in the denominator. So it's going to give me y, 2 plus 7 is 9, so y to the 9. Now afterwards, I'm going to work with the z's, but I notice that one's on top, one's on the bottom. They're actually being divided. That's why the fraction's in the middle of it. So I'm going to simplify this. But what do we say we're going to do? When we divide exponents, when we divide bases, we're going to subtract the exponents. I'm going to do bigger minus smaller and put it wherever the bigger base is. So I'm going to do 3 minus 1, which is 2. And I'm going to put it wherever the bigger z is. So it's going to go z to the 2 on the bottom. And that's it. And that's how we do it. Okay? So when you're multiplying bases with the product rule, you're going to add the exponents. When you're dividing bases with the quotient rule, you're going to subtract the exponents. And just leave it wherever the bigger exponent is. So if you want to try B, work on B on your own, and then press play. So for B, I notice that I have a lot of bases with exponents as well as numbers. So what I'm going to do is I'm going to first clean it up by putting B to the first power. And then I'm going to create a fraction. And I'm going to simplify 10 and 2, which gives me 5. 10 is bigger, so I'm going to put it on top. I'm going to work with the A's. There's 2 A's on top, so there's a to the 5th, a to the 3rd. I'm going to add them. I'm going to add the exponents, so it's going to be a to the 8th in the numerator. I'm going to go to B because I like to go alphabetical order. B to the 1, B to the 3. I'm going to add the 1 and 3. It's going to be B to the 4 on the denominator. And then lastly, I have C squared on top and C to the 4th on the bottom. So I'm going to divide the exponents. I'm going to divide the bases, which means I'm going to subtract the exponents. I'm going to put bigger minus smaller. So I'm going to do 4 minus 2, which is 2. And I'm going to put it wherever the C is bigger, which is in the denominator. So I'm going to put C to the second power, and that's my final answer. Okay? They get trickier, but if you stay organized, you have a better success of getting these right. Hopefully you did. So now we move on to example 4. Now in example 4, we're going to be finally using the power rule. The power rule is whenever you have an exponent to an exponent. The hardest part about this is what happens when you have a number and then variables. Well, remember what we said, we treat numbers individually than variables. So take a look at the first example. We have 3x cubed y second raised to the 3rd. Technically, that means there's 3 of these together. But an easier way of doing this is actually working this out. Think about it. What is 3 raised to the 3? 3 raised to the 3 is 3 times 3 times 3, which would be, what number? It would be 27. But when it comes to the bases, what you're going to do is you're going to actually multiply the exponents. So when you have x cubed raised to the 3rd, you're not going to do 3 to the 3rd. you're actually going to do 3 times 3, which is going to be 9. So this is going to become x to the 9. Then on my next one, I have y squared to the third, which again, you multiply bases in the power rule. So 2 times 3 is y to the 6. And that's my final answer. Now, the tricky part about this is notice what happened. For the actual numbers, I raised it to that power. 3 cubed is 3 times 3 times 3, which gave me 27. But to the bases, I actually multiplied all the exponents. That's called the power rule. So now moving on to B, I'm going to do the same thing. 2 cubed is 2 times 2 times 2, which is going to be 8. I don't like A by itself. Remember, what number we're going to put as the exponent? We're going to put 1. So now I'm going to multiply these bases. 1 times 3 is 3, so it's going to be a to the third. I'm going to go to the B. B cubed raised to the third is 3 times 3, so it's going to be b to the 9. And then I'm going to move on to C, which is c squared raised to the third. It's going to be c to the 6th. And that's my final answer. So with these, you have to be super careful. Okay, now we're moving on. Now C is a trick question. Anybody remember why? Because it was a slide and we said that in the zero exponent rule, whenever you notice that your entire base has an exponent of 1, what's your answer always going to be? 1. That's it. So every single time you guys notice that you have 0 as an exponent, your entire problem turns into 1, and that's it. Okay? Okay. So now we're going to move on to example 5. Example 5 is working with the negative exponent rule. Now, we touched upon it a little bit in the previous slides because negative exponent rules do have a special way of being worked out and played. I'm very interested in us getting rid of the exponent first to make it positive so it becomes easier for us. So in the first problem, I'm going to notice that there's a number 2. 2 is perfectly fine. And there's an exponent of negative 2 in the denominator. But we said that if you ever have a negative exponent, we have to move it. Where does it go? The opposite. If it's in the bottom, it goes to the top. If it's in the top, it goes to the bottom. So always remember that you're just going to move the variable either up or down depending on where it's negative. So if I have an exponent that's negative on the bottom, I'm going to move it to the top. So how do I do that? This is what I do. Because I'm starting off with a fraction, I like to start off with a fraction as well. 2 is perfectly fine, so I'm going to leave 2 on top. But the x to negative 2 on the bottom, I don't like it. So where am I going to put it? I'm going to put it at the top. When I move it to the top, the exponent turns into a positive. And now I don't have anything else in the bottom. So what happens? I could either put a 1 on the bottom if I want to, or my answer would just be 2x squared. And that's it. Now we move on to B. Ask yourself, where is the negative exponent? The negative exponent is in the numerator. So if it's in the numerator, I have to technically move it somewhere to clean it up. So what I'm going to first do is I'm going to ask myself, okay, let's work with x first. X comes before y, so we're going to work with x. X to negative 2. I don't want the x on top, so I'm going to move it where? The bottom. It's going to become x squared on the bottom. Now I'm going to go to the y. Y to the 4 is perfectly fine. So what am I going to do with that? I'm going to leave it exactly where it's at. But now I don't have anything on the numerator, so what do I put? Whenever you don't have anything in the numerator because everything moved from it, you're simply just going to put a 1. But now I have to leave the 1 there because it's a fraction. So this would be my final answer. 1 over x squared and y to the 4th. So now moving on to C. If you want, pause the video, practice it, and then play the video when you feel like you're stuck or you have the answer. So now C starts off with a fraction. So I'm going to also create a fraction. I'm going to look at all my variables and numbers. I see 3, b to negative 4. The biggest misconception in this problem is people think 3 and b belong together. They do not. Numbers are individually worked on from variables. Numbers and variables are different. So when I look at 3, 3 is perfectly fine, so I'm going to leave 3 just 3. It doesn't have a negative exponent, so I'm not going to work it and bring it down. But I'm going to go to my a to negative 3, because remember, alphabetical order. A to negative 3, I don't like a in the bottom, so where's it going to go? It's going to go on top. Where? Next to the 3. But then I have a b to negative 4 on top. I can't have that, so where's it going to go? It's going to go to the bottom. And then now, that's my final answer. 3a to the cube over b to the 4th. So every time that you have a negative exponent, the negative exponent rule tells you to move the negative and the base either up or down depending on its location. Okay? And then when you move it, it turns positive. But again, treat numbers differently from variables. Okay? So now we move on to example 6. Now example 6 is going to be us actually doing a combination of product, quotient, and the negative rule. So we're going to label it using simplifying your answer by using the negative exponent rule, but to be fair, it's a combination of all three. So this is where we're going to combine all the rules, but to be fair, we said we're going to first always get rid of negative exponents. Okay, so we're going to first use that rule, and then it'll lead us to everything else. So you ready? Let's do the first example. In the first example, we have 2 on top, and then you're going to notice you have a fraction with a whole bunch of variables. So what we're going to do first is we're going to create a fraction, and all I'm going to do is I'm going to clean it up. So 2 is normal, so I'm going to put 2 on top. I have x, which I'm going to still go in alphabetical order. I have x to 2 on top, but if you notice in the bottom, I have an x to negative 2, which I can't have. So what do? I bring that x to negative 2 to the top, but what happens to the exponent? It becomes positive, and I'm going to copy it by putting x to the second. I'm going to move on to the y. I have a y to cubed on top and a y to 3 on the bottom, which is perfectly fine. They're not negative exponents, so I'm going to leave them how they are. Now I have a z to the third on top, and I have a z to the fifth on the bottom. Because they're not negative exponents, I'm going to leave them exactly where they are. Now you'll notice I have a very clean basis with exponents. So now my next step is let's actually get started. So we're going to actually divide them. Or multiply, depending on where we're at. So 2 is by itself, so I'm simply going to put the 2 on top still. Now I have to work with the x's because I'm going alphabetical order again. So I have x a second, x a second. What happens when they're technically next to each other? They're being multiplied. So what do I do with the exponent? I add them. So in the numerator, it's going to be x to the 4. I'm going to move over to the y's, but notice something. What do you notice about the y's? I have y to the third on top and y to the third on the bottom. Technically, I would divide the exponents, right? And I'll get 3 minus 3, which is 0. But what is anything to 0? It's what? It's 1. So because of that, anytime that you notice that you have the same base to the exponent as the same base to the exponent on the bottom, they're going to simply just cancel out. Your answer will be 1, but I have so many things other that's in the problem already, I don't have to write the 1. Okay, so always cancel them out. And then lastly, I have z to the cubed over z to the fifth, so I'm going to subtract them. 5 minus 3, bigger minus smaller is 2. Where is it bigger? It's bigger on the bottom. So in the denominator, it's going to become z to the second, and that's my final answer. So step 1 is always to clean everything up by moving all the negative exponents, and then use a product or quotient rule that follows. So now, if you're ready, pause the video, try B, and then press play, and I'll be here to answer the question. So moving on to B. First thing I see is fractions with a lot of negative exponents. So what am I going to do? I'm going to create a fraction, and I'm going to put everything in alphabetical order. So x to negative 2 over x to negative 3. I don't like that, so I'm going to move them. In the numerator, it's going to be x cubed. In the denominator, it's going to be x squared. The y's and the z's are perfectly fine, so we're going to leave them as such. So it's going to be y to the 10 over y to the 4. Z cubed over z to the 5. Now I'm going to simplify the exponents. So I'm going to create another fraction, and I'm going to do x cubed over x squared, which means I'm dividing, so I'm subtracting the exponents. 3 minus 2 is 1. I'm going to put it where it's bigger, so x is going to go to the top. I don't need the 1 because this is my final answer, but if you want to write the x to the first, that's fine. Y to the 10 over y to the 4, I'm going to subtract the exponents. 10 minus 4 is 6. 10 is bigger, so it's going to go on top. Y to the 6. Z cubed over z5, I'm going to subtract the exponent. It's 2. I'm going to put where it's bigger, which is on the bottom. And that's my final answer. Hopefully you got that right. So now we move on to C. Again, if you feel ready, pause the video and then press play when you're done. Step 1, create a fraction, move everything. 3 and 9 stay where they're at because they're just numbers. A to the 4 stays on top, but a to the negative 3 is going to go on top. So it's going to be A3. B to the negative 4 on top has to go to the bottom, so it's going to be B to the 4. And then B to the 8 is going to stay right next to it. Now, once I'm here, my next step is to simplify. So I'm going to draw another fraction. I'm going to simplify 3 and 9 as if you're dividing. They both 3 goes into both of them, so this is going to become 1 over 3. A4, A3 are next to each other, so they're going to be adding the exponent because you're multiplying. So the product rule, so it's going to be A to the 7. And then on top, in the denominator, B4, B8, you're going to add the exponent, so it's going to become B to the 12. Now, you could write this answer without the 1 because you already have an A to the 7th. So you could write it as A to the 7 over 3B12, or simply just keep it just like this. And that's it. So you have to be careful with all of these exponents. But if you can do this properly, there's nothing else that I can throw at you that's going to confuse you because you know all your rules. But step one, always move your negative exponents. That's going to help you out the most. So now we move on to our last topic, which are working with rational exponents. Now, rational exponents can be tricky just because of the fact that you have to always look at the exponent, and your exponent is going to be a fraction. The word rational represents fraction. So the first step I want you always to remember is this. If you see a rational exponent, go back to the first slide that we worked on. You're going to have to rewrite it. This is something called an index. So we said what we're going to do is we're going to cover the denominator, which means your exponent is going to be a to the first. What does that mean? That means that I'm going to have a to the first in the inside. So what we're going to do is we're going to write a to the first in the inside. You're going to write a root, and then the index is right here. You're going to put your denominator. So in this case, it's going to be 3. Now, since I don't really need the 1 because a is by itself, I'm going to write this as 3a, 3, the third root of a. That's how I'm going to write it as. Okay? Now, the way you say this, by the way, this radical represents the word root, and the number on the outside represents the index. So when to say this, you're going to say the third root of a. You pretty much go left to right. So now we move on to b. Again, put your finger over the 5, and then on the inside I have b to the second. But because there's a denominator, I know there's going to be a root. What's the root? It's going to be 5. Where am I going to put that? In the outside. How do I write this? It's 5 root b to the second. Now c, I'm stuck. I can't do it. Why? There's a negative exponent. Where does this go? It goes to the top. So I'm going to first clean it up. I'm going to write this as 1x to the half. Now, I don't really need the 1, so I'm going to keep this as x to the half. And then when I clean this up, again, cover the denominator. If I cover the denominator, it's going to say x to the first. And then because there is a denominator, that index is going to go on the outside, which is a 2. Now, the fun fact about this is actually going to be called the square root. Because any single time that you don't see a 2, it means that it's the square root. So this is something that I wanted to say for last, and I wanted to make sure that you went over. If you ever see the square root of x, the reason why it's called a square is because there's 2. That's why sometimes you don't see that 2, because it's technically invisible, the same way that we write the 1 as the exponent of x. So the way we would write this is the square root of x, and that would be our final answer. So if you never see an index number in the front of the root, it's because it's a 2. And every other number you would have to write like we did in the other examples. Okay? So these do get tricky, but the easiest way to do this is cover the denominator, write the base with the exponent, and then the denominator is going to go on the outside of the root as the index. So moving on to the last couple slides. Last couple slides is just working with bases, and the easiest way to do this is this. Every time that you're working with numbers raised to a root, you want to break that number down to its fullest. So for example, think about what number to what power gives you 8. You can think of prime factorization, which you've done in the past, but sometimes you're supposed to be really good at this point because we're in algebra 1. So think about what number to what power gives you 8. Think small numbers. 2 times 2 times 2 gives you 8. So what does that mean? That means it's going to be 2 to the third raised to the 1/3. Now, why am I doing that? I'm doing this because look what happens. I just created a base to an exponent, but now it's being raised to another exponent. So now we have to use the power rule. What happens when I have an exponent to an exponent? I multiply. So if I go to the side, I'm going to write 3 over 1 times 1/3. And if you remember, if you multiply across, and you're going to get 3 over 3, which is simply just what number? It's just 1. So if I were to rewrite this, my answer would become 2 to the first, or simply just 2, and that would be my final answer. So when it comes to working with rational exponents and simplifying, you want to remember this. If you have a number you want to simplify by breaking it down, by either using prime factorization or using the numbers that you're good at. So for 27, I'm going to try prime factorization this time. So I see 27 raised to 2/3. It's a rational exponent, so I'm going to break down 27. If you use prime factorization, you're thinking about the factor tree. What times what gives you 27? So I know 3 times 9 gives you 27. You can break up 9 to be 3 times 3. So because of that, I have 3 3s remaining. So my answer is going to be 3 cubed raised to 2/3. But again, I have a power to a power. So what do? I go to the side, I put 3 over 1, and I times it by 2/3. Now, using a shortcut, these 3's are going to cancel out. So I'm left with just 2 over 1, which is simply just 2. So that means that this is going to become 3 to the second power, which is simply just 9. And that's my final answer. So it must feel like we're doing a lot, but we're really not. We're breaking down the base to make it as simple as possible. So when we simplify it, we can either do a factor tree, just know the numbers off our top of our head. And then when we have a power to a power, we have to make sure we multiply them, go to the side, make sure you get them right, and work it out. So now you're going to notice C is a negative exponent, but we've been doing this already. You should be good at this. I want you to pause the video, try it on your own, and if you get stuck, just press play. So for C, the first thing is I don't want a negative exponent. So what do? I'm going to bring this entire base up. There's a 1 on top, but I don't need the 1, so this is simply just going to be 9 to the 3/2. Once I do that, it's going to look identical to the previous problem. So what I'm going to do is I'm going to break up 9. I'm going to work with numbers I know, what power to what number, what number to what power gives you 9. I hope you agree it's 3 to the second. If you did prime factorization, it would have been 3 times 3. And then afterwards, I'm going to keep the exponent as it is, 3/2. I now have to go to the side. It's going to be 2 times 3/2. I'm going to make it 2 over 1, so it's a fraction. And then I notice these 2's cancel out. So my answer is simply just going to be 3 over 1, which is just 3. So when I combine this, it's going to be 3 cubed. And I know that 3 cubed is going to be 3 times 3 times 3, which is going to be 27. And that's going to be your final answer. Now, these take some practice. So it's something I would recommend to do homework and practice problems because you want to make sure you're good with these numbers. Okay? And that's how we do rational exponent rules. So now in our last slide, what we're going to be doing is we're actually going to be simplifying these radicals with these random indexes. Now, we're going to assume that all these variables are going to be positive, that none of them are going to be negative. You will learn a rule later down the road in a future math class that's going to teach you how to work with some indexes in case these variables are going to be negative. But for this time, we're going to assume they're all going to be positive. Now, the simplest way of doing this is to ask yourself, how many times does this index, this number on the outside, go into each number? Go into each number. Now remember, when we were working with exponents, we always treated them individually. We treated them on their own so that we don't get confused. So when it comes to this, I'm going to do the same thing. I'm going to ask myself, 3 goes into 12 how many times? 4 times. So because of that, my answer for x is going to be x to the 4 because it went in evenly. I'll move on to y. 3 goes into 9 how many times? 3 times. So on the outside, it's going to be y cubed. And then the last one, I'm going to do 3 goes into 3 how many times? 1 time, right? 3 goes into 3 1 time. So I'm going to be left with z to the first. But do I really want to write the 1? I don't. So I'm just going to write z, and I'm going to circle my answer. The reason why I'm done is because everything came out evenly, perfectly. And that's the best trick to know how to work with indexes and when you're simplifying rational exponents with variables and exponents. So now I'm going to move on to my next one. I have a 5 as an index, so that means I want to ask myself how many times does 5 go into 10 and 5 go into 5. So I'm going to do them individually. 5 goes into 10 how many times? Twice. So this is going to become x to the second. And then I'm going to go 5 goes into 5 how many times? 1 time. So it's simply just going to be y to the 1 or just y. And that's my final answer. That's it. So now we're going to move on to C. But wait a minute. C doesn't have an index. So what does that mean? That means it's technically an imaginary what? An imaginary 2. Now, I want you to do the first one. X to the 4th. 2 goes into 4 how many times? 2 times. So it's going to be x squared. And it went in perfectly fine, so it's perfect. But then I go to the next one. 2 goes into 5 how many times? And you're going to say it doesn't go into 5. And you're right, it doesn't. So you're going to learn that sometimes there's a remainder. When there's a remainder, that means it's going to stay in the inside of the radical, so you're going to put this on the side. So what you're going to do is you're now allowed a remainder, so you have to ask yourself, how many times does 2 go into 5 evenly? It goes into evenly twice, right? 2, 4. So because it goes in evenly, I'm going to put y to the 2 on the outside, but you have to ask yourself, how many were left? Well, remember, 2 times 2 is 4, but I was supposed to get to 5. You were left with 1. So one of the y's, y to the first, is going to be left over. Does it get tricky? It does. It does. It's complicated, but you have to remember, what goes in perfectly goes on the outside. What has a remainder goes in the inside. So now I'm going to move on to the z to the second. I'm going to do the same thing. 2 goes into 2 how many times? 1, so it's going to be z to the 1 on the outside, but I don't need it. Now, there wasn't a remainder, so I wouldn't put anything in the inside. So my final answer is going to be x squared, y squared, z, and the square root, which I don't need, so I'm going to erase it, and then y, I don't need the 1, and that's my final answer. So now when you move on to d, I want you to try the same thing. But understand there's allowed to be remainders. So I'm going to try this one as well. 4 goes into 6 how many times? Once, but there's a remainder. So what does that mean? That means I'm going to put the 4th root on the outside. Now I'm going to split this up a bit. So 4 goes into 6 how many times? Once. So it's going to be a to the 1 on the outside. And then what's your remainder? It goes in 1 time, so it's 4. I have 5, 6. So it's 2 remainder. So a to the 2 is going to be in the inside. I'm going to move on to b. 4 goes into b cubed how many times? It doesn't. So because it doesn't, you can't take anything out. So your remainder would be 3. So I'm going to leave the inside as b cubed. I'm going to move on to c to the 8th. So 4 goes into 8 how many times? Twice. So it's going to be c to the second power. And then lastly, 4 goes into 10 how many times? Twice evenly. 4, 8. So because it's twice, I'm going to put d to the second power. And then what's the remainder? There's 2 because 4, 8, I'm missing 9 and 10. So on the inside, it's going to be d to the second. Then I'm going to clean this up. It's going to be a c squared d to the second, the 4th root on the outside, and then the inside is going to be a squared b cubed d to the second. And that would be my final answer. So is this simple? It's not. It's not. I wish it would be. But what the trick is, every single time that you see an index on the outside, ask yourself how many times does it go evenly into the exponent. However many times it goes in evenly goes on the outside, and whatever your remainder is goes in the inside. And that'd be your final answer. So this was a tough lesson, but if you were able to understand all the rules, which I want you to write down, have them forever because you're going to use them all the times when it comes to exponents. Remember, bases are always going to be simplified if you're able to. If not, you're going to work with the exponents. So best of luck. Thank you for watching, and I'll see you next time.